Hello viewers, in today's class we are going to take up some important problems based on applications of differential equations. So the first problem is assume that a spherical raindrop, right? So suppose we have a spherical raindrop whose radius is say r and v is the volume, right? And s be the surface area. So the problem is assume that a spherical raindrop evaporates at a rate that is proportional to its surface area. If its radius originally is 3 millimeter and 1 hour later has been reduced to 2 millimeters, find an expression for the radius of the raindrop at any time. So here the radius is r, v is the volume, and s be the surface area. Now here we are given that the rate of change of volume, that is rate of change of volume, which can be written as dv over dt. So the rate of change of volume, because the raindrop evaporates, right? So there is a change in the volume of the raindrop. So the rate of change of volume is given to be proportional to its surface area, right? So we are given dv over dt is proportional to surface area. Now if we remove this proportionality sign, we introduce a constant that is k, right? So dv over dt is equal to ks, where k is the proportionality constant. Now what we will do, we'll substitute the value of the volume and surface area. So the volume of this spherical raindrop, this is the raindrop, so the volume is 4 over 3 pi r cube, right? And the surface area is 4 pi r square. So let us substitute the value of v and s in this equation. So what we will get, we will have d by dt of the volume, that is 4 by 3 pi r cube, and here we have k times 4 pi r square, right? Now 4 pi over 3 is a constant, so we can write 4 pi by 3, and here we have d by dt of r cube, and here we have 4 pi k r square, right? So now this 4 pi and 4 pi get cancelled, and we have 1 over 3, and dr cube over dt is 3r square dr over dt, right? And here we have kr square. So now 3 and 3 get cancelled, so dr over dt can be written as kr square over r square, which is equal to k, because r square and r square get cancelled. So we have dr over dt is equal to k. So the rate of change of the radius is equal to the constant of proportionality. So now this is a differential equation, and we have to solve this differential equation. So separating the variable, because this is a variable separable form, and we can write this equation as dr is equal to k dt, right? Now integrating both sides, what we will get, we have integral dr, then integral of k dt, and here we have a constant of integration, that is c. So integral dr, that is r, and here we have kt plus c. So this is the expression for the radius of the raindrop related to time, right? So here r is equal to kt plus c. Now we are given some conditions here, and we can find out the value of k and c by using these conditions. Now here we are given that if its radius originally is 3 millimeter, right? So at t is equal to 0, we have r is equal to 3 millimeters, and after 1 hour the radius is reduced to 2 millimeters. So at t is equal to 1 hour, the radius becomes 2 millimeters. So let us first substitute this value here. So what we will get, here we'll have 3, and here we have k times 0 plus c, so therefore c is equal to 3, right? And substituting the value of c here, we'll get r is equal to kt plus 3, right? Now we have to evaluate this constant k by using this condition. So substituting this condition in this equation, so r is equal to 2, so here we have 2, and k times t is equal to 1 r, so here we have 1 plus 3, right? So this is 2 is equal to k plus 3, and solving this equation we'll get k is equal to 2 minus 3, that is minus 1, right? So now if we substitute the value of this k is equal to minus 1 here, we'll get r is equal to minus t plus 3, right? And what we want to evaluate, we have to find an expression for the radius of the raindrop at any time. So r is equal to 3 minus t. So this is the relation between the radius and time, right? And here the condition on this time t is t must be greater than or equal to 0, but less than or equal to 3, right? So this is how we apply the concept of differential equations to solve these problems. Now let us take another problem. So here we have to solve this problem using differential equations. So the problem is find the equation of a curve passing through 1 comma pi by 4 if the slope of the tangent to the curve at any point p x comma y is y over x minus cos square y over x, right? So here we are given a curve, say this is the curve C, and at any point, right, at any point say this is the point P x comma y, the slope of the tangent, right? Suppose this is the tangent, and the tangent is denoted by t, so the slope of this tangent, so the slope of the tangent at this point P x comma y is given as y over x minus cos square y over x. So the slope of the tangent is given by y over x minus cos square y over x. Now we know that the slope of the tangent is denoted by, right, the slope is it can be calculated by using the derivative of y with respect to x. So this is the slope of the tangent, and the slope is dy over dx. So we can write dy over dx is equal to y over x minus cos square y over x, right? So here we have framed a differential equation. So this is the differential equation of this curve, right? And we are also given a condition that this curve passes through this point 1 comma pi by 4, right? So now our aim is to solve this differential equation. Now we see that this is a homogeneous differential equation, and this homogeneous differential equation can be solved by substituting v is equal to y over x, right? Or in other words, we can say that we can write y is equal to vx, where v is a function of x, right? So y is equal to vx. Now differentiating both sides, we can write dy over dx is equal to v times derivative of x is 1, and then we have x times dv over dx. So dy over dx can be written as v plus x dv over dx. Now substituting the value of dy over dx as v plus x times dv over dx here, and for y over x we can write v. Clear? So combining this equation, and this expression, so this equation number 1, it becomes v plus x dv over dx. For dy over dx we have substituted this value is equal to y over x is v minus cos square y over x is v, right? So this equation number 1, it becomes this one, right? Now this v and v get cancelled, so we have x times dv over dx is equal to minus cos square v, right? Now this differential equation becomes a variable separable form, right? Variable separable form. So here we can separate the variables by writing dv over cos square v is equal to minus dx over x, right? And this can further be written as secant square v dv is equal to minus dx over x, right? Now integrating both sides, we'll have integral of sec square v dv is equal to minus integral of dx over x plus c, right? Now the integral of sec square v is tan v, right? And here we have integral of 1 over x is log x, right, plus c. Now resubstituting this value v is equal to y over x here, we have tan y over x is equal to minus log x plus c, right? So this is the general solution of this differential equation, right? But here we'll now find out the particular solution, because here we are given this condition that the curve passes through 1 comma pi by 4. So utilizing this condition, we'll find the value of c. So now the curve passes through 1 comma pi by 4. The curve passes through 1 comma pi by 4. So it means we can write x is equal to 1 and y is equal to pi by 4, and we'll substitute these values in this equation, right? So what we will get, this is tan and y is pi by 4, x is 1, and here we have minus log. For x we have 1 plus c, right? So this is tan pi by 4 is equal to minus 0 plus c, because the value of log 1 is 0, right? So this is c, and tan pi by 4 is 1, so c is equal to 1. So substituting the value of c here, we have tan y over x is equal to minus log x plus 1, right? So this is the particular solution of this differential equation. Now this equation can also be written as tan y over x plus log x is equal to 1, right? So this is the required equation of the curve which is obtained by solving this differential equation. Now we can also express this equation in the form of y is equal to f of x, right? How? Let us see. So we can write tan y over x is equal to 1 minus log x, and this 1 can be written as log e minus log x. So this can be written as log e over x by making use of the properties of log. So tan y over x is equal to log e over x, right? And taking this tan to this side in the form of inverse function, so y over x is tan inverse log of e over x, and taking x to this side, we have y is equal to x times tan inverse log e over x, right? So this is the equation of this curve in the form of y is equal to f of x. Now let us take one more problem. So here we are given if the marginal cost of manufacturing a certain item is given by c prime of x, which is dc over dx, is equal to 2 plus 0.15 times x, find the total cost function, given that c of 0 is equal to 100. So here we are given the differential equation that is dc over dx is equal to 2 plus 0.15 times x. So here C of x is the cost function, and C prime of x, that is C dash x, denotes dc over dx. So this is the differential equation, and we have to find C of x, that is we have to find the cost function, right? So we'll solve this differential equation, and if we inspect this differential equation, we see that this is again a variable separable form, and we can write this equation as dc is equal to 2 plus 0.15 times x dx, right? Now integrating both sides, so we have integral of 2 plus 0.15 times x dx plus c, right? C is the constant of integration. Now the integral dc is c, and the integral this integral of 2 dx is 2x, and this is 0.15, and the integral of x is x square over 2, and here we have c. So here we can write say c1 is the constant of integration, right? Constant of integration, because here we have denoted the cost function by c, so we are taking the constant of integration as c1 instead of c, right? So this is equation number 2. Now here our aim is to find out this constant of integration by making use of this condition, right? So c of 0 is equal to 100. It means when x is 0, the value of c is 100, right? So let us substitute these values in equation number 2. So we'll get 100 here. This is 2 times 0 plus 0.15 times 0 square over 2 plus c1, and here this term becomes 0, this term becomes 0, so we have 100 is equal to 0 plus 0 plus c1, so c1 is 100, right? Now substituting the value of c1 equal to 100 in equation number 2, we'll get c is equal to 2x plus 0.15 x square by 2 plus 100, right? Or in other words, we can write it as c is equal to say 4x plus 0.15 x square plus 200 divided by 2, right? So this is the required cost function c of x.